Number 10. In the diagram, we have two similar triangles. And what I'll do again is to try and just sketch them. So let's just assume that's the smaller one, and we have this larger one. Now the smaller one is A, B, D, and this is A, C, E. And we have some lengths here. We have 9 and 10, and here we have 22.5, and that's about it. And here we have 17. So calculate the length of CE. So let that be X. So using these two similar triangles that I've sketched, we can take the ratios of the corresponding sides. So basically X, which is CE, over 17 should be equal to 22.5 over 9, which implies that X should be equal to 22.5 multiplied by 17 over 9, and that will give us 42.5 centimeters. And then DE, it's part of AE, so we can find AE first, and then we can use that to find DE. So to find AE, we'll take the ratios of the corresponding sides. So y over 10 will be equal to 22.5 over 9. So y over 10 will be equal to 22.5 over 9, which implies that y will be equal to 10 multiplied by 22.5 over 9. And if you plug that in the calculator, that will be equal to 25 centimeters. So basically, but that's not what's required. We want to, what's required is DE. So DE will be equal to 25 minus 10. So DE will be equal to 25 minus 10, which will be equal to 15 centimeters. All right, the next part, the area of triangle ABD is 36. So the area of this is 36. So they want us to find the area of this quadrilateral here, BDEC, this one here. So first of all, we can find the area of the larger triangle, which is ACE, and then find the differences between the areas of the two triangles to find the area of the quadrilateral. That's the plan. So the ratio of the lengths of these two triangles, so the ratio of the lengths will be equal to 22.5 over 9, which is 2.5. So the ratio of the areas will be equal to 2.5 squared, which will be 6.25. So the area of the larger triangle, which is SCE, so area of SCE will be equal to 6.25 multiplied by the area of the smaller triangle, which is 36, and that will be 225. So the shaded area will be the differences between these two areas. So shaded area will be equal to 225 minus 36, which will be equal to 189 centimeters squared. And that's basically how you work out that question. Right. Number 11. So we have two rectangles which are similar here. We have E, F, D. Um, so and we have the larger one. So what I can do here, what I'm going to do is just to sketch the two rectangles separately. So we have this one here, which is the smaller one, and then we have the larger one. So the smaller one is this one here, yeah, which is DAEF, this one. So if I rotate it anti-clockwise 90 degrees, I'm gonna end up with this rectangle here, ADFE, but the other one remains the same, ABCD. So what you're interested here is basically on identifying the corresponding lengths. Now for a rectangle, this is easy because you know that opposite sides are equal anyway. So for example here, if we know that the length for this AD is 4, and we know that the length for the larger one it's 10. We also know that the width for the larger one is 4 here. So we can be able, by looking at these corresponding sides, yeah, that corresponds to that, and also that side there corresponds to that. Then we can be able to find the ratio of the corresponding sides, and from there we can move ahead and find the ratio of the corresponding areas, and then find the area of the required shape. So before we carry on, we need to find the missing length, this one here. So let me just call it X. So that is the width of the smaller rectangle. So and you can find that by taking the ratios of the corresponding lengths, which will be equal. So X over 4 should be equal to 4 over 10, which implies that X will be equal to 4 multiplied by 4 over 10. That's 1.6. So X here will be 1.6. So the area of DAEF, um, DAEF, which is the smaller one, so area of DAEF will be equal to just length times width. I mean, it's a rectangle, so um, instead of taking a longer route, this is probably the easier route, and that's just equal to 6.4 centimeters squared. Okay, last question. The diagram shows two regular hexagons, and we have all this information, and then we have OF, which is from here to here, is 3 times OA. So if OA is X, this will be 3X. And then the area of OABCDA, so which means the area of the smaller one, the area of this. So area here is 4 centimeters squared. So they want us to find the area of the shaded region. So let's first of all, so the plan here is to find the ratio of the lengths and then find the ratio of the areas, the larger hexagon as compared to the smaller hexagon. And then once you find the ratio of the areas, you can find the area of the larger hexagon. And then after that, you find the differences between those two areas to find the area of the shaded part. So the ratio of the lengths will be equal to 3x over x, which is just 3. The ratio of the areas will be equal to 3 squared, which is 9. So the area of the larger hexagon, so that's a large hexagon, will be equal to it's 9 times the area of the smaller one, so 9 multiplied by 4, which is 36. So the shaded area will be equal to 36 minus, which is the area of the larger hexagon, minus the area of the smaller one, which is 4. And that will give you 32 centimeters squared. That's basically how you solve this question.